People have been aware of elements since ancient times. With improved understanding of elements, scientists began to experiment with ways to organize them, searching for patterns to make better sense of their characteristics and to help predict the properties of elements yet to be discovered. Dmitri Mendeleev was the first to organize a table similar to the one we use today. When elements were ordered by increasing atomic weight, a pattern showed where properties of the elements repeated regularly or periodically. The periodic table is a masterpiece of a simple systematic tool of organized chemical information. The evolution of chemistry's periodic table into the current form is an astonishing achievement, with major contributions from many famous chemists and other eminent scientists. The periodic table allows for easy understanding and recalling the properties of the many elements and is the cornerstone of fundamental scientific knowledge. Elements are classified according to their properties. The major categories of elements are the metals, nonmetals, and metalloids. Furthermore, there are rows or periods that extend horizontally, illustrating recurring trends in the chemical behavior of the elements as their atomic number increases. There is also importance on the element's vertical placement. Groups or columns are explained under modern quantum mechanical theories of atomic structure as containing elements that have the same electron configurations in their valence shell or outer energy level. The groups are numbered numerically from 1 to 18, beginning with the leftmost column, the alkali metals, to the rightmost column, the noble gases. Lithium with atomic number 3 is in the first group, the alkali metals. There are several exceptions regarding the periodic table, and one is that hydrogen is in the first column, but it is not considered to be an alkali metal. The rest of Group 1 consists of lithium, Li, sodium, Na, potassium, K, rubidium, Rb, cesium, Cs, and francium, Fr. The alkali metals share many similar properties. They are all shiny, soft, highly reactive metals at standard pressure and temperature. As with all metals, the alkali metals are malleable, ductile, and often softer than other metals. They all have one electron in the outermost orbital. The alkali metals are also known as alkaline metals, but there is a separate group called alkaline earth metals that is very different. The alkali metals are highly reactive metals that do not occur freely in nature. They are highly reactive because they only contain one electron in their outer shell and are ready to lose that one electron in ionic bonding with other elements. Alkali metals can explode if they are exposed to water. They are good conductors of heat and electricity. Cesium and francium are the most reactive elements in this group. Francium is very rare due to its extremely high radioactivity and thus occurs only in traces due to its presence in natural decay chains. Lithium is a rare element with atomic number 3, found primarily in very small amounts in molten rock and salt water. It is non-vital in human biological processes, although it is used in a multitude of drug treatments because of its positive effects on the human brain. Due to its reactive properties, it is utilized in batteries, nuclear fusion reactions, and thermonuclear weapons. Lithium is most commonly found combined with aluminum, silicon, and oxygen to form minerals. Although these minerals can be found on each of the 6 inhabited continents, lithium is primarily mined in Australia, China, Bolivia, and Chile. Mining for lithium is becoming less essential because newer methods have been developed to make use of the lithium salts found in salt water. Of all the Group 1 metals, lithium is the least reactive. It takes more energy to remove lithium's one valence electron than it does with other Group 1 elements because lithium's electron is closer to its nucleus. Lithium has a high electrochemical potential, so it is useful as the anode in batteries. An anode is an electrode through which positive electric charge flows into a polarized electrical device. In rechargeable batteries, such as for cell phones and laptops, lithium ions move from the negative to positive electrode when discharging, and vice versa when charging. Lithium is the lightest known metal and can be alloyed with aluminum, copper, manganese, and cadmium to make strong, lightweight metals for aircraft. What is the difference between alkali metals and alkali earth metals? Right next door to the alkali metals is the second most reactive family of elements on the periodic table, the alkali earth metals in Group 2. The alkali earth metals include beryllium, Be, magnesium, Mg, calcium, Ca, strontium, Sr, barium, Ba, and radium, Ra. These elements are referred to as alkaline because when mixed with solutions, they are likely to result in a pH greater than 7. Beryllium is a lightweight steel gray colored element with atomic number 4 and is the first of the alkali earth metals in Group 2. Beryllium can be produced in cosmic rays but is short-lived. It is also relatively rare on Earth. Countries such as the United States, China, and Kazakhstan are the top producers in industrial-scale extractions of beryllium. The extraction of beryllium from its compounds is a difficult process. It is a divalent element which occurs naturally only in combination with other elements in minerals. It is found in beryl gemstones such as morganite, aquamarine, and emerald. Beryllium has 12 known isotopes, but only one of them, beryllium-9, is stable enough to occur naturally. Beryllium combines with many nonmetals to form binary compounds, such as beryllium oxide, a white solid that has a high melting point, making it useful in engines, spacecraft, radio equipment, and semiconductors. In the healthcare industry, beryllium is used because of its very low absorption of X-rays and is therefore implemented in radiation windows for X-ray tubes and MRI machines. Because it only has 4 protons, beryllium is relatively transparent to energetic particles. Therefore, it is used to build the beam pipe around the collision region in particle physics setups, such as all 4 main detector experiments at the Large Hadron Collider. The low density of beryllium allows collision products to reach the surrounding detectors without interruption. Its stiffness allows a powerful vacuum to be produced within the pipe to minimize interaction with gases, and its thermal stability allows it to function correctly at temperatures of only a few degrees above absolute zero. Its properties also keep it from interfering with the magnet systems used to steer and focus the particle beams in the Large Hadron Collider. However, scientists are researching potential substitutes as beryllium is expensive to produce and has safety restrictions because of its toxicity. Careers in these fields are rewarding and exciting due to rapid advances and the demand for better products. Scientists and engineers are constantly striving for better, longer-lasting batteries or more stable materials to use in space. Students interested in careers in these fields should focus on chemistry and engineering. The knowledge of elemental properties and behaviors has helped scientists and engineers decipher the best uses for elements in countless applications. For an excellent interactive version of the periodic table of the elements, please visit www.ptable.com.